Welcome to the massive open online course on Aspen Plus. In this lecture, we shall study about the root ID and creating one's own property method. In the last lecture, we have discussed about the property methods in detail, but they were already available property methods in Aspen Plus domain. But in today's lecture, we shall discuss about how to create one's own property method based on the available models we have or customized model that we can add in. Now, before that, we have to find out what is root. The root is, as we know, that property method is nothing but a combination of different models, and the models are nothing but set of equations. Now, while calculating a property, physical property, we have to use these model equations judiciously one by one. There should be a protocol that the data set goes from the first set of equation to the next set. From the next set, the result will go to the third set, and so on, until we get the desired properties that we have. So entire path, the calculation path, is called the root. And each and every root has a separate ID. By choosing the root ID, we can set that we want to go through this root to arrive at this desired property, physical property. So this method root is a combination of property method and the models which are used to calculate the property. Now, one can view, clone, modify, and create one's own root. That means you can clone an already present root and then you can edit them to create your own. So we shall see an example which says create a customized method which is based on ideal method and take some property models from activity coefficient and equation of state models to customize the new method. What does it mean? We will clone the ideal method first. We will name it some XYZ model, and then we will know that ideal model has some root ID where some property methods are described. We shall chop them out and take up some activity coefficient model method and add into this. So that will be our new property method. Obviously, it is for advanced users who can make these things work. So we will learn how to do this. For that, we have to go to the Aspen domain. Let us take a system, say benzene and toluene. Press next. Let us say ideal model. Run. Yes. Now, just go to selected model and you will find ideal. Now, what I need to do, I want to create a new thing. So my new model is, say, I use it as my prop. So it is my property method. And my property method, the base property, that is the property from which I want to clone it, will use ideal property method. The moment I do it, all the ideal property roots, root IDs and properties, they come over here. Okay. Now, what is this? This is vapor fugacity coefficient of a component in mixture. And what is this? This is vapor fugacity coefficient calculated using ideal gas model. Now let us change it. So instead of this, I will use vapor fugacity coefficient calculated using Redlich-Kwong-Soave model. So instead of 0, 0, if I choose this one, it is no longer ideal method. The base is ideal, but I have changed the root ID. Okay. We can create a root ID in the very first place. So for that, we just take new my root. And what is my root? What is the property name? Let us say property is vapor fugacity coefficient of a component in a mixture. Clone root from, this is from ideal gas. Vapor fugacity coefficient calculated using ideal gas model. So we have cloned the root. This is the model name. Ideal gas equation state model. This model is used for ideal property method. Let us change it. Let us change it to let us look for the Redlich-Kwong-Soave. Yeah, polymer-Soave Redlich-Kwong equation equation of state model. This model is used for poly SRK property method. So let us use it. Okay. So my arrow root is fixed. Now go back to our property method. Select the root ID. Choose my arrow. This is my root ID. That way, I have changed it from ideal method to Redlich-Kwong-Soave method. But only for vapor fugacity, not for others. Now let us say I want to change the, what is this? This is liquid mixture surface tension. Liquid mixture surface tension, I do not like this one. So I go to root, create a new liquid surface tension with this ID. Let me check. Liquid surface tension. Clone it from say this one and change the model to this one. So this is our LST root. Okay. Now go back to my prop and instead of SL00, sorry, I have to check this one, right? Yeah, surface tension. So it's for pure component, I believe. So pure component. Yeah, liquid pure component. And here I find my model, user defined LST. So like that, I can change a lot of them and we can create my prop. Now in specification method, instead of ideal, I can use my prop method, which is user defined, and I can use it to run the property method. Okay. So it gives some result. Now this result may be very stupid because while changing them, I didn't give enough thought process. So this particular example, it may not mean anything. But for an advanced user, this changing the property method is a very good and very effective method to target more and more accuracy for a simulation. So next is property set. Now what is property set? It's a collection of thermodynamic, transport and other properties used in the physical property tables and analysis. Now Aspen Plus has several built-in property sets that can be used for various applications. Each simulation template has its own built-in property set that can be used while creating a new run. Or you may not use any one of them. You can start from scratch. Okay, I will give an example like that and we can try one. These property sets can be modified as per use and need. Few available properties are as follows, like thermodynamic properties for pure component, thermodynamic properties in a mixture, such as constant pressure, heat capacity of a mixture or viscosity of a mixture, electrolyte properties, properties related to petroleum products. Now this example has been given. Select a chemical template, include property sets to report, run a flash with an equimolar mixture of benzene, phenol, water and at 140 degrees centigrade and atmospheric pressure, define your own property set. Now we may not use this. We may start from scratch, because if you learn how to start from scratch, then you can definitely do how to begin from chemical template, because in chemical template already some basic work will be done. Let us learn how to do it from scratch. For that, let us go back to our flow sheet. What do we have here? We have benzene and toluene, but here it is written equimolar mixture of benzene, phenol and water. So we have to add phenol and water. Then we have to run a flash 140 degrees centigrade atmospheric pressure. So go to simulation. We don't have anything, so let us add a flash, bring in material, streams. Let us name this as feed, vapor and liquid. Press next. This is 140 degrees centigrade and 1 atmosphere pressure. So 140 degree and 1 atmosphere pressure. And it's an equimolar mixture, so write benzene, phenol and water, all of them 1. And then go to next. It will ask for flash option, so let us say heat duty 0 and pressure remains 1 atmosphere. This is the flash tank. Okay, go back to properties again. First we can delete this toluene, because toluene does not add to our system. So delete it. Okay. Select ideal property method. And then run. Okay. Now the results are available. Just go to the result. Okay, sorry, we have not run the simulation. So run the simulation first. Yes, now the results are available. So go to stream result. And here you will find this information. So what are the stream result information we have? We have temperature, pressure, molar vapor fraction, molar liquid fraction, solid vapor fractions, enthalpy, entropy, density, and so on. Molar flow rate, we have mole fractions, we have mass flows, we have mass fractions, we have. In the vapor phase, we have this information, and in liquid phase, we have this information. But we do not have any more information which you might want to know. For that, we have to generate a property set. Here, create a new property set. So we can name it as my P set. Okay. Now it is saying, what are the property sets that you want? Physical property. You may want to know the, say, the free energy of a pure component, or say free energy of a mixture. You can set the unit in kilojoule per kilomole. You may ask for CPMX, CPMX and μmax, that is constant pressure, heat capacity, and viscosity of a mixture. So just write CPMX and μmax. So Cp, you can check the unit as kilojoule per kilomole K, and mu you can choose centipoise, not a problem. And the qualifier, you have to choose liquid phase or gaseous phase. So let us say we want it for vapor phase. Done. Now let us go and run the simulation. Okay. Now go check the simulation results. Here you have to add the properties. Here you do not have anything. You can add properties. While adding the properties, you will have the combination at the bottom. My P set gives energy, my P set heat capacity, my P set viscosity. So you can click all of them and click OK. Then you have these things added along with all of them. Press OK. The moment you press, you have these things in vapor phase. So what is the Gibbs energy, what is the heat capacity, and what is the viscosity of mixture. But I have got in vapor phase. We don't have the same thing in liquid phase. Do we have in liquid phase? No, we don't. We don't have it in liquid phase because we have not asked for. If you go back to my P set, if we go back to my P set, you can check. We have a qualifier, and this qualifier is only in vapor phase. But if you want the same information into liquid phase as well, you have to choose liquid. So both vapor and liquid are available. So just go and run it once again. Go to stream results, add properties, come at the bottom, click them once again, press OK, and then press OK again. Okay, and then you get all of them in vapor phase as well as in liquid phase. So that is how you can create your own property set, and for each simulation you can drag that property set from the definition to its result section, so that every time you do not have to repeat it. Once the property set is met, that is fixed over there. Only during the simulation you have to add in. So we end our lecture at this point. So in tomorrow's lecture, we shall start with analysis tools. Thank you.